Test, 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 test. Okay, we're just gonna wait one more minute and then I'll get started. Alright, hello everyone. Today you are here probably because you wanted to know how to analyze sentiment analysis from movie reviews. So I am Tahmid, a technical coordinator from the Artificial Intelligence Society here at UT Dallas, and I'm here to answer that question while guiding you through this workshop. And I sincerely apologize for the background noise. Please bear with me for a few seconds. Okay, extremely sorry about that. Um, but yeah, so in this workshop, we are going to analyze sentiment from movie reviews. So, what is sentiment analysis? Sentiment analysis is a technique to figure out whether some given data is positive, negative, or neutral. So, but why do you need to analyze sentiment, right? So, sentiment analysis is useful for quickly gaining insights using large volumes of textual data. So say, think about movies. Sentiment analysis can be used to focus on a reviewer's feedback verbatims, where the sentiment is strongly negative. Likewise, we can look at positive reviewers' comments to find out why these um, viewers love this movie so much. Now, obviously, making movies is an art form. So just because you have a lot of data doesn't necessarily mean you can make a good movie. But this does tell the maker how other people perceive the movie, how they feel about the movie itself. Now, one great example of sentiment analysis is stock trading companies who trawl the internet for news. Here, sentiment algorithms can detect particular companies who show a positive sentiment in news articles. This can mean a significant financial opportunity, as this may trigger people to buy um, more of the company's stocks. Now, having access to this type of data gives traders the opportunity to make decisions before the market reacts. Now, in this particular project, this will be our roadmap where initially we will be collecting our data set. We will be creating environment by importing different libraries for our data set. And then we are going to apply certain super popular pre-processing techniques on our data to make the analysis of sentiment a little bit easier. Afterwards, we're going to split our data for training and testing. We're going to build our model, and finally, we're going to test to see how our machine learning model works. Now, the data set. So, IMDb was super helpful by releasing a data set in Kaggle where they have over 50,000 movie reviews. Now, I am going to link this in the chat real quick. So, the way IMDb's dataset is structured is we have two columns, one containing the reviews, the other containing the sentiments. And the reviews are mapped to the sentiments, right? So each of these reviews are from actual human beings, and they're around 200 words each. So in these reviews, you will notice very common human errors where sometimes the sentences aren't as coherent as you want them to be. Sometimes you're going to find weird symbols. Sometimes you're going to find misspelled words, which is good for us because we do want to analyze the reviews from human beings. Now, let me just... Okay, so we want to import certain libraries so that we can build the environment for our project. And in a few seconds, I'll show you the Google Collaboratory, which will be linked, hopefully. So what libraries are we planning on using here? So we are going to be using Pandas, which is an open source data analysis and manipulation library. It's super popular. It's also used in industry, and overall, it's very powerful. We will be using this to import our data set and then a little bit of data manipulation. We will also be using the NLTK library. Well, it's a suite of libraries that with a bunch of programs that make natural language processing super easy. And we will be using it to do things like extract stop words, tokenize, limitize, and these are all things that I will be describing very soon. And okay, and now for the libraries that are more machine learning focused. SKlearn is super popular. You'll probably see it in other machine learning projects as well. And we will be using it to basically split our data set for training and testing. And then we will use it to build a machine learning model that will extract the sentiment. Now, before we want, before we, wait, before I go into pre-processing, let me just show you the code real quick. So I will be linking the Google Colab. Now we have our data set, we have our library. So over here, we're importing the data manipulation libraries that we want. Just NLTK, and then SKlearn. Yeah, so does anyone have any questions regarding these? Feel free to ask in the chat while I try to link the Google Colab. All right, so once you access the link to the Colab, be sure to make a copy in your own drive. That way you can manipulate this as much as you want. You can run these the way, yeah. You can run these the way you want and just check it out. So, right, before we try to extract sentiment from the data set that we have, we need to perform certain pre-processing tasks to make the data more, the extraction a lot easier. So we start off by converting all of the casing to a certain, we convert all of our text to either upper or lower case. And the reason for that is having um having a bunch of upper cases and a bunch of lower cases don't really tell you anything about the sentiment, right? And so what we are going to do is we're going to create a function called preprocess underscore review, and we are going to pass in the data set. And then over here to deal with the casing, we are going to do review.lower. So after that, we are going to remove noise. So noise refers to unwanted links, punctuations, weird symbols or icons that we might find in the dataset. So we do that. We remove URLs with the help of the like the re library, with the it's regular expressions. And if you're familiar with Python, it's fairly simple to understand. We then remove punctuations over here, and then we remove like some super common symbols that you might find. Okay, so after that's done, we want to tokenize our data. So what does it mean to tokenize? Say this is a line. This is a string that you have. So when you run the word underscore tokenize function from the NLTK library, it basically divides your data into small clusters. This really helps um, the functions that we like. This really helps the us do the next few pre-processing steps that we are planning on doing. So after we're finished tokenizing our data, which something like this, so we tokenize the data, we are going to remove stop words. Now, stop words are super popular in NLP, and these are basically a set of commonly used words in a language that does not help us extract any information. So, determiners, prepositions, coordinate conjunctions, etc., these are all stop words, and we don't need them in our data. And since we don't need them, we are going to remove them. And we do that by, well, Python's really cool because it can do for loops in like one line. Um, and this is what we do here. So review tokens is our current data set. So in review tokens, we each of the elements we are considering as words, and we have our stop words list, which we created earlier from the NLTK library. So if a word in review tokens is in the stop words list, we remove it, and we are putting the new clustered text in filtered words. So finally, the final pre-processing technique that we are going to use here is lemmatizing. So lemmatizing means converting a word to its dictionary form. So yes, the reason we want this is just to simplify our data. For example, say we have words like run, runs, ran, running, etc. Um, but the lemma for all of this is run. So, oops, my apologies. Another great example is like am, are, is, has, have, words like those. They all stem from be. By lemmatizing our words, we can make the textual data look a lot simpler because we're removing suffixes, prefixes, and we're just tenses. Yeah, we're just making it super easy to be super easy for the sentiment to be extracted. So we are going to call this function. So just an example of our the function, the preprocess underscore review function that we defined here. Hello, this is a test line, then weird signs, and this cleans itself up and becomes hello test line. So we have removed punctuations, we removed different cases, we don't have stop words, and everything looks fine for now. Over here, I am uploading my data set. It's in my personal drive, so if you guys want to do it, I have some YouTube links here. It's super easy. Um, you'll figure it out, I know. Alright, so now that we have our pre-processing function, we want to pass it through the reviews column so that the textual data there we can clean up the textual data, right? So we do that soon. Okay, so currently this is what our data set looks like. We have the reviews, we have the sentiment. And now what we're going to do is we are going to create a new column in our dataset called cleaned underscore review. So we use the pandas library, and then we pass our data set into the function. And after doing that, this is what we have. This is the new column that we've created, where we have our cleaned up data. So I kind of went on my own here, but it's okay. Alright, now that our data is clean and we're ready to extract sentiment from it, we will start building our model. So first things first, we want to split parts of our data, parts of the data set for training and testing. And we do that with the help of SKlearn. SKlearn has a train test split function, which pretty much does most of the stuff for us. So we have 45,000 reviews for training and then 5,000 reviews for testing. Now, okay. So, something to know about this particular project is term frequency, like TF-IDF. TF-IDF vectorization. So this is really cool. So TF-IDF is a statistical measure that evaluates how relevant a word is to a document in a collection of documents. So term frequency, as the name suggests, is the number of times a certain word shows up. And the formula for it is right here. So number of times a word repeats in a sentence over number of words in a sentence. Now, inverse document frequency is the rareness of a term. And with the help of TF-IDF, we are very easily able to figure out, we're very easily able to create a model that is able to extract the sentiment from these data. Now, we are going to convert them into convert our textual data into vectors with respect to the sentences, and then we are going to perform logistic regression. So regression is a type of predictive modeling technique which is used to find the relationship between a dependent variable with one or multiple independent variables. Now, logistic regression is a classification algorithm used to predict binary outcome based on a set of independent variables. Now, this is useful to us because all the sentiments in our case is either negative or positive. It's a binary outcome instead of a categorical one. So through the help of logistic regression, we should be able to create a model that can solve our problem here. Now, another thing to learn is what a pipeline is. So a pipeline enables us to assemble several steps that can be cross-validated together while setting different parameters. And there's not really much I can tell you about here. Okay. So the way you do it is just something to remember. We import a TF-IDF vectorizer from SKlearn. The same thing we did for train test split. And I also believe we do the same for logistic regression. Yes. Okay. So, yes. First, we create a TF-IDF vectorizer object called tvec. and then we create a logistic regression object called CLF2. Now, we declare an object called model, which is a pipeline with the vectorizer and the classifier. Afterwards, we fit in our training data, and after the model is done, which it is not, because I didn't split it. Okay, so now all of the training data is going to pass in, and the model is going to start training itself to figure out, it's going to try and predict how what the sentiment might be through the review. Now, let's just do this. Okay, so after we fit in our data, we train it, and then we remember that we split data into train and test. So we have testing data. We try to predict results using the testing data just to see how accurate our model is. And we can see from here that our model has an accuracy of 0.8962, which is an 89%. It also has a precision of 0.89 and recall of, well, it's 0.9, and the recall of 0.9, which is pretty cool. Alright, finally, you can pretty much put in any review here and see how well your model is doing. So if we have this, if we run it, it's going to tell us it was a positive review. This movie was bad. It tells us that this was a negative review. And yeah. And that's pretty much a very basic understanding of how to make a sentiment analysis model through machine learning. But yeah, um, thank you for coming to the stream. I know I have been very disorganized. I apologize, a little tired, but yeah, have a good day. I'll be here for 5 to 10 more minutes if anyone has any questions, so feel free. Um, so yeah, running the Lambda function on the dataset usually take uh it depends on like PC to PC. It varies a lot. Um, but it usually does take time. Obviously, if you have a very big data set, it's gonna take longer than compared to having a smaller data set. But yeah, short answer is yes, it does take time. Oh yes, and before you guys leave, do fill out the post event survey. Super helpful. Pretty please.